SAP S/4HANA is the absolute authority for an enterprise's financial and operational state. It serves as the single source of truth for every accounting document, inventory movement, and final audit control. Yet despite the massive investment required to maintain this system, business and finance teams continuously extract data out of it just to do their day-to-day work. To reconcile accounts or match invoices, organizations rely on massive Excel workbooks, custom SQL server databases, and expensive point-to-point reconciliation tools that operate entirely outside the ERP. The root cause of this constant extraction is an agility mismatch between the database and the business requirements. SAP is an online transaction processing system. It is explicitly designed for strict transactional consistency, a requirement that inherently resists the rapid iterative changes needed for analytical logic. Modifying business logic directly inside SAP requires writing custom ABAP code, navigating slow release cycles, and clearing rigid transport management protocols. Attempting to run heavy analytical joins inside the system, like matching millions of ledger rows against external bank feeds, degrades core HANA performance and rapidly inflates memory licensing costs. Simply piping SAP data into a conventional cloud data warehouse does not solve the logic problem. It shifts the compute bottleneck to a new environment and introduces multi-minute ingestion latencies that disrupt active operational workflows. The solution is not to build another dashboard. The goal is to establish a governed, highly performant business logic layer that sits entirely outside the ERP monolith. True operational agility requires permanently decoupling iterative business rules, exception handling, and reconciliations from the ERP, while strictly preserving its transactional integrity. SAP S/4HANA remains the base authority for final accounting and audit controls. To avoid licensing penalties, data extracts exclusively via official SAP interfaces, routing into a low-cost object storage layer. Here, data lands as immutable Parquet files. Unlike conventional cloud data warehouses, requiring data to load into proprietary systems, this architecture decouples raw storage from expensive compute licensing. Open transactional items remain active for rapid querying, while cleared historical items permanently compress in cold storage. As the analytical foundation, these raw SAP extracts remain strictly read-only, ensuring total auditability. This physical separation isolates heavy analytical reads, scaling to process billions of rows, and eliminating primary storage cost bottlenecks. Uncontrolled extraction into object storage leads to file proliferation. Generating thousands of small Parquet files eventually cripples query performance. To organize these files, we introduce Duck Lake as the necessary table format governance and metadata layer, positioned directly on top of the object storage. Duck Lake runs automated background compaction jobs, continuously merging small extract files into optimized, high-performance columnar blocks. The storage layer is now optimized, requiring a compute engine capable of querying massive files instantly, without forcing data into a separate warehouse. Optimized storage needs instant querying without moving data. Enter hybrid compute, a MotherDuck cloud node, and an embedded DuckDB gear. MotherDuck handles shared state and aggregations, while embedded DuckDB runs inside application microservices, scanning Parquet files directly with zero latency. By evaluating complex business rules directly on the raw files, DuckDB bypasses standard multi-minute ingestion and ETL pipelines entirely. For developers, logic built and tested locally on embedded DuckDB scales instantly to massive cloud datasets on MotherDuck without requiring code rewrites. While the Duck stack handles high-speed analytics, functional applications need state tracking. We attach PostgreSQL laterally as the operational database to manage application configuration, access control, and workflow state machines. This stack reverses traditional data processing. Instead of forcing data into a rigid compute engine, it brings zero-latency compute directly to the governed storage. With infrastructure established, we evaluate the application layer. Tasks like cache application and freight reconciliation are core business challenges, not vendor-specific ERP problems. Traditional architectures suffer from cross-system blindness when forced to match internal ledgers against external non-SAP datasets, like daily bank feeds or carrier invoices. External data streams like bank and carrier feeds skip the ERP entirely, landing directly in object storage. These disparate files morph into uniform data blocks. Embedded DuckDB then executes high-speed matching and AI-driven fuzzy logic directly in memory. Matching completes in fractions of a second because the system queries raw files directly. Unmatched exceptions are automatically routed to a lightweight Postgres-powered user interface for human review. Once matches are approved, we hit a critical guardrail. The application layer must never execute a direct write-back to SAP's underlying database tables. Instead, the system generates a structured, approved payload that posts securely back down to SAP via standard APIs, under strict service account authorizations. By abstracting complex logic into the Duck compute layer, the ERP is freed from analytical bottlenecks, operating purely as a highly scalable system of record. The measurable business impact of this architecture is best demonstrated through a high-volume financial reconciliation proof of concept. Look at this dashboard comparison. A manual month-end reconciliation process that traditionally took 3 full days is consistently condensed down to 15 minutes. That velocity is achievable because the heavy analytical joins were entirely removed from the transactional ledger. Implementing this model requires specific enterprise guardrails. It is a conditional go architecture. First, the architecture enforces bring-your-own-bucket configurations. Raw SAP data never resides in third-party managed storage. Second, it requires strict column-level security to dynamically mask sensitive financial data and personally identifiable information before it reaches the analytical layer. Mother Duck and DuckDB should not be evaluated as mere reporting accelerators or as Snowflake alternatives. This decoupled hybrid stack provides a foundational runtime for high-performance decision intelligence applications that remain independent of the underlying ERP.